welcome to lesson 3, definite integrals. So we're going to do two things today. First of all, we're going to learn how to do definite integrals, and second of all, we're going to learn why we do that and practice using it in context. Okay, a little bit about notation first. You should all, I think, be comfortable with this. If you start with dy by dx and you integrate it, you're going to get the y is equal to something or other plus the constant. We also did a little bit of this one last lesson, f dashed of x. When we integrate it, we get f of x. But there is a third type as well, and we're going to be using that quite a lot today. This weird sort of elongated s, that means integrate. And so this means integrate 2x with respect to x. Now you don't need to worry too much about why we have to put that there, I just want you to remember to put it there for now. And they all mean the same thing. They're just different ways of doing, it's just different notations. But as I said, we're going to be using this one today. So, let's go straight into using that. If we wanted to integrate this from x equals 1 up to x equals 4, what we're going to find is that we no longer have a constant. So if we integrate x squared plus 3 with respect to x from 1 up to 4, and I put the limits of integration on the side of this integral sign here. And what we do is first of all just the same thing as before. I'm going to put the answer in square brackets. When I integrate this, I'm going to get x to the power of 3 over 3 plus 3x. Now you see, instead of having the constant, I don't need it anymore because it is a definite integral. From 1 up to 4, these ones here. And what that means is we're actually going to find a value for this. Now I'll explain what that gives us at the end of this lesson, more like halfway through, but anyway. 4 to the power of 3 over 3 plus, 3 multiplied by 4. So what you can see here is I've substituted in that x is equal to 4. And now I'm going to substitute in the second limit. We're going to have 1 to the power of 3 over 3 plus 3 times 1, which is just 3. Okay, I can sort this out a little bit first. So what we're going to have here is 4 to the power of 3. 4 times 4 is 16, times by 4 again is 64 over 3 plus 12 minus 1 over 3 plus 3. You'll see that it's everything in this last bracket which is going to be minused. So again, all we have to do is type that into our calculators. So we've got 64 divided by 3, add on 12, minus third, and then 3. And you should get an answer of 30. So when we do a definite integral, you will always end up with just a number. Let's do another example, just to get our heads around it. You will often see this. Evaluate this integral. Okay, what does that mean? Well, if we look it up, the first one, to draw conclusions from examining, to assess, okay, but in mathematics, it specifically means to compute an expression. Okay, so what we're going to do is we are going to work out the value of this. We are going to compute that expression there. So, this is difficult to integrate, so first of all, I'm just going to expand those brackets. So I'm going to keep the integral sign here because I haven't integrated it yet. When I expand those brackets, I'm going to get x squared plus 1x minus 3x, so I'm going to have minus 2x minus 3, and I'm integrating with respect to x. So now I am going to integrate, so I lose the integral sign, I'm going to replace it with these square brackets, and I'm going to integrate each of these terms in turn. X to the power of 3 over 3 minus 2x squared over 2 minus 3x. Remember, no need for the c. It's a definite integral from minus 1 up to 3. Okay, so now I've integrated it, and I still need to use our limits of integration from minus 1 up to 3. So I'm going to substitute these in now. I'll have 3 to the power of 3 over 3 minus, well, those two 2's can cancel that, so I've just got x squared. That would be 3 squared minus 3 times by 3. And from that, I'm going to minus everything that I get when I substitute in minus 1. So substituting in minus 1, I'm going to have minus 1 to the power of 3 over 3 minus negative 1 squared minus 3 times by negative 1. Okay, I'm going to tidy that up a little bit before I use the calculator. I'm less likely to make mistakes that way. 3 to the power of 3 is 27 divided by 3 is 9. Minus 9 minus another 9. Negative 1 cubed. Negative 1 times negative 1 times negative 1. It's going to give us a negative. Negative 1 over 3 minus negative 1 squared. Well, that will be a positive, but I'm still minusing it, so it's going to be negative 1, minus 1. And I've got minus 3 times by negative 1, which gives me 3. I might even simplify this just a little bit further. 9 minus 9 is 0. Minus the 9, we're just going to have minus 9 from the first bracket. The second bracket, I'm going to be lazy. Minus the third, minus 1, plus 3. And it gives us 5 over 3. So I'm minusing from that 5 over 3. So our final answer then is negative 9 minus 5 over 3. Which gives us negative 32 over 3. And I'm just going to leave it as a top-heavy fraction. Okay, so that is definite integrals. If we just recap on that, I expanded out the brackets. I then did the integration, so I lost the integral sign because I've done the integration, replaced it with square brackets. I left the limit of integration here. I then substituted in the first, so the top limit here. Substituted it in, and I minus from it what I get when I substitute in the bottom limit. I then worked out all the numbers, simplified it, and finally got an answer. Okay, your turn. Pause it, and I'll go through them. Okay, this one here, might move over to the side of the board in a moment. When I integrate it then, question 1, when I integrate that, I'm going to get our square brackets. I'm going to have 3x to the power of 3 over 3. And we're going from 1 up to 2. So from 1 up to 2. Let's simplify that first. So we're going to have x to the power of 3 over nothing. Just x to the power of 3. And that's from 1 up to 2. So then when we substitute in, we're going to have 2 to the power of 3 minus 1 to the power of 3. And that gives us 8 minus 1, which is equal to 7. And that's our answer. Okay, second one looks slightly more difficult. Let's give it a go. When we integrate it, we lose the integral sign, and we have the square bracket there instead. 4x to the power of 4 all over 4 minus 2x squared over 2 plus x. And we're going from 2 up to 5. Let's now simplify that before we substitute in. We'll have x to the power of 4 minus x squared plus x, and that goes from 2 up to 5. So now let's substitute those in. So that's going to be equal to the top limit, 5 to the power of 4 minus 5 squared plus 5, minus from it the second limit, 2 to the power of 4 minus 2 squared plus 2. And I'm going to be entirely lazy this time. I'm just going to type the first bracket into my calculator. 5 to the power of 4 minus 5 squared plus 5 gives me 605. And I'm going to minus from it the second bracket. 2 to the power of 4 minus 2 squared plus 2, which is 14. So my final answer is 605 minus 14, which gives me 591 as my answer. Okay, that is the end of the first part of lesson 3. That's actually quite a lot, so I might maybe switch this and say that I've told a lie. And the start of this lesson I said that we were going to learn why we do all of this. That's going to be in lesson 4 now instead.